Allora, innanzitutto vi devo ringraziare, siete venuti in tanti, vi avevo pompato, ho detto venite assolutamente. In effetti è un evento più unico che raro, quindi avete fatto benissimo a venire, grazie per essere venuti. Il nostro presentatore di stasera lo conoscete già? Stasera si parla di qualità del codice, quindi è un argomento che dovrebbe piacere a tutti. La presentazione si dovrebbe chiamare, beh, poi ve la presenta lui, quindi cazzo mi metto a presentarla io. Un paio di informazioni di servizio. Allora, le cose importanti. A marzo c'è la Kotlin Night, se vi interessa, che è il 15. Ok, giusto? Il 15 marzo si parla di Kotlin, ci sono persone che conoscono Kotlin, quindi, quindi io non ci sono. Quindi ci sono, niente, ci sono persone che conoscono Kotlin e quindi se avete delle domande o comunque vi piace Kotlin venite anche il 15 marzo. Ve lo consiglio perché lo organizza il nostro caro Vasco, che quindi è in collaborazione col JVM User Group, quindi insomma un marchio di qualità. Scusate, un'altra cosa importante. Stasera è il 99esimo incontro del JVM User Group Milano. Avevamo quasi pensato in onore del nostro ospite di rinominarlo nel 100esimo. Sapete come fa Microsoft quando salta una versione di Windows o Apple quando salta una versione di macOS 10? Ma alla fine non l'abbiamo fatto. Quindi questo è il 99esimo, quindi il 100esimo è solo una scusa per dire che non abbiamo portato niente per festeggiare. Quindi lascio la parola a Gianluca.
Ciao, questo sì. Ciao a tutti. Chi ha già visto la presentazione? È un botto, raga, un botto. Dall'ultima mi sa non molto. Questo è difficile che la cambi, questo è troppo bello, mi dispiace, raga. Vabbè, io non sono cambiato, sono sempre uguale, mi trovate così su internet, piacere Gianluca. Di solito sto così quando faccio le presentazioni, stasera è così. Questo sono io a lavoro, faccio il programmatore e in realtà stasera mi sento più così, perché stasera siete davvero un botto e poi vabbè c'è Venkat, quindi insomma. Allora, lasciamo perdere me, parliamo di qualcosa di più importante, tipo lo spazio. Cos'è sto spazio? Dove siamo? È un coworking, no? Tipo il Talent Garden, tipo il coworking? No, ok? Questo non è un coworking, questo qua è l'ufficio di un paio di aziende. La principale è Mikamai. Mikamai nasce nel 2007 su queste due cose in rosso, il rubino sta per Ruby, che è un linguaggio di programmazione che viene dal Giappone, e Rails invece è il framework di sviluppo web scritto in Ruby più famoso, ok? Mikamai lavora con queste tecnologie e con altre, no? Fa un po' di sviluppo mobile e poi lavora appunto anche con altri linguaggi e framework. Questi un po' sono i clienti di Mikamai, ok? Mikamai lavora con aziende in ambito gaming, finance e moda principalmente. In realtà però qui dentro Mikamai lavora con altre aziende, una di queste è LinkMe, che fa lo stesso lavoro di Mikamai ma con altre tecnologie. Un'altra azienda è JUG, sono uno studio di design. E qua c'è un po' una breaking news perché c'è un'altra azienda, che è questa, che non lavora direttamente con Mikamai, LinkMe e JUG, ma che in qualche modo collabora con loro nel contesto delle community. Questa azienda è l'azienda per cui lavoro io. Io prima lavoravo in Mikamai, adesso lavoro per Credimi. È un'azienda, una startup, fintech, ha come prodotto finanziario anticipo fatture. Cos'è che unisce tutte queste aziende? Okay? L'amore per le community. So che sembra una roba molto, molto così, a supercazzola, ma credetemi davvero, quello che unisce queste aziende è la volontà di offrire un servizio a titolo gratuito che possa essere fruito, ovviamente gratuitamente, da parte delle community che ne hanno bisogno, quindi uno spazio dove potersi incontrare. Questa è la lista di eventi che ormai non aggiorno più da tempo immemore. Ovviamente fra gli eventi e le community che ospitiamo c'è il JUG Milano, 99esimo incontro, ragazzi, sono tanti. Io ringrazio sempre, stasera ringrazio ancora di più perché insomma c'è Venkat, quindi grandissimo ospite. Un'ultima cosa, prima di lasciarvi alle cose più succulente della serata, fra un mese esatto c'è una conferenza, qui mica mai, tratta di un mondo totalmente diverso da quello della JVM, si parla di Elixir ed Erlang, quindi ecosistema BIM. Nonostante sia un mondo talmente diverso, io ho un'opinione che è volemo se bene, quindi ragazzi, se siete interessati, fra un mese, qui mica mai. Ok, questa è la mia mail, sempre mail di mica mai perché continuo a seguire le community per mica mai e credimi. Per qualunque cosa scrivetemi. Adesso vi lascio davvero alla ciccia della serata e buona serata, buon divertimento.
All right, welcome to 12 ways to make code suck less. Thanks for having me here. Thanks to Mario for inviting me here, all the JUG leaders for making this happen, and for you to be here spending your precious evening with me. So I want to talk about something that we all care a lot about, which is our ability to create software and stay sane as we create it. We are creating software, but quality is something that catches up pretty quickly. It becomes really hard. I'm going to say there are maybe 4 kinds of people out there. There are the what kind of people. They'll keep asking you, what are you doing? What are you doing? And then there are the how kind of people. How do you do this? And that's what they all want to know. Then there are this when kind of people. When are you going to get done? Maybe managers, right? And then there are these why kind of people like me. Why are you doing it? If you cannot convince me, I would rather not do it. So I'm going to start with the question, why should we really care about quality of software? The why question. Well, the first question here, of course, is why should we care? And I'm going to say that one of the reasons I care about quality of software is we cannot be agile if our code sucks. As simple as that. What is agile development? It is about the ability to respond to change even late in the game. But you're sitting there in a meeting and they're telling you that we need to make a change to this XYZ module, and then you realize the last time you touched the XYZ module, you couldn't go home for the weekend. You're gonna convince them this is not a good change to make. So if you want sustainable agility, quality is extremely important. I was going to just say that's the reason, but I then realized there is one other reason why we should really care about quality. Because quality is how we tell our colleagues how we feel about them. Do we love them or do we hate them all? This is one of the ways to tell that. Well, when we develop code, there's always somebody who comes behind us to maintain the code. And how do they feel? What do they say? What were you thinking when you were writing this code? It becomes really hard. But of course, the question is, how do we really improve the quality of software? Well, the first law of programming says lowering quality lengthens the development time. So if you really want to go slow, you want to really create really bad quality software. That'll slow you down very quickly. But if you slow down to improve the quality, you actually gain speed in the long run. And of course, the question then is, what is quality? How do you tell that something is really good quality? We have to be a bit careful about it. I used to work with a guy who had a very weird definition of quality. He said, this code is great because I wrote it. I don't think that's a good definition. So we need to really have the question, what is quality? So here's my definition of quality. I'm going to say the quality of code is inversely proportional to the effort it takes to understand it. If a code is of really good quality, you spend less time understanding it. If a code is of poor quality, you spend more time to understand it. I do a lot of code reviews, and I tell my developers, you want me to spend very little time with your code. The more time I spend is more trouble for everyone, including me. So we want to really be able to get in and understand the code, and that becomes very critical. So we'll talk about 12 ways to really improve the quality of code. But I'm going to start counting down, and the first one is actually a bit non-technical. And I'm going to say the first is to schedule time to lower technical debt. Well, everyone will tell you they have technical debt, right? That's universal. Everyone has technical debt. Well, the term technical debt was coined by this gentleman here, Cunningham. And he was working in the financial industry, and he realized that the financial world has financial debt, and similarly he said the technical world accrues technical debt. Well, in the financial industry, what happens if you don't pay your loan on time? that leads to a financial bankruptcy. Similarly, in the technical world, we suffer with code almost to the point of declaring technical bankruptcy. Nobody wants to work with that piece of code because it becomes so horrible to maintain over time. Now, imagine I keep charging my credit card every month, and I realize that I don't have to pay all the amount in full. I can just pay the minimum balance. What a great idea. I start sending the minimum check, and very soon after a year, I realize that I've exceeded my credit limit. What does the bank do? They send me a letter saying, "Dear Venkat, you have exceeded your credit limit." But you see, the bank really cares about me. They don't want me to get into trouble. They want me to get into real trouble. So they increase my credit limit, and I keep spending it. And after a while, I realize the amount I owe is more than the yearly salary I make. What do I do? The only option I can think of is to grow a beard, change my name, and move to another state. Just for the sake of records, that's not the reason I left the state of Texas. But the point really is, it becomes unbearably hard to maintain it, and that's exactly what happens with the technical bankruptcy also. So we want to take the time to pay it quite often. But of course, the question is, what is technical debt, and how do we really get to it? Unfortunately, there are times you don't have to do anything to get technical debt. Oh, that framework that you used on the project 6 months ago, you didn't have a reason to change it, but the framework has changed quite a bit, and now it's 4 versions ahead, and you better change it. Oh, that schema you have been developing for a while is totally out of shape. You need to put the time to really refactor it. You haven't had the time to do it. But let's not confuse technical debt with writing intentionally poor quality code. That's called an act of sabotage. That's not technical debt. So we have to be a bit careful when we coin these terms. But when it comes to technical debt, one of the things I ask developers is not if they have technical debt, but I ask them, can you show me a list of your technical debt? So in the work area, on the wall, I want to see those listed. Because a lot of times we talk about technical debt during the sprint meeting, and we talk about it when we are in a review. But in the middle of the day, when we are actually working, I want that to be on the wall so we can look at it. So on the wall, I want a list of technical debt with the most important, the most critical to the least important listed in the work area. So when we are working every single day, it's on our face, we can look at it. But in addition to it, we need to really take the time to pay technical debt. It doesn't have to be all or nothing proposition. So we have to schedule time to pay the technical debt. Well, typically in a project, we are taking time for development. We also, schedule time for planning. We also schedule time for meetings. Everybody loves those meetings, isn't it? We also schedule time for vacation and sickness. Some companies don't give time for vacation, and people take more sickness. Kind of works out. But the point really is, we schedule these times on a sprint. Well, in a similar way, we should also actively schedule some time for paying the technical debt. So we could say in the next sprint, now that we have listed the technical debt, the very first one, he's going to spend 15% of his time on it. Well, the second one, he's going to spend 15% of his time. The third one, maybe she'll spend 10% of her time on the third one. So we will schedule it across the team so that we can all actively spend some time, not just in development, but also in paying these technical debt as well. But in addition to this, there is one other thing we have to be very careful about. And this really resonated well when I heard this from this wonderful lady. And she said something that really shook me up. Her name is Linda Rising. And Linda said, a freeway that's filled with cars is a parking lot. That's a beautiful metaphor. If you take a freeway and put a lot of cars on it, what does the freeway turn into? It turns into a parking lot. You're literally driving very slowly, almost to a grinding halt and moving, just inching away, and that becomes really painful. In a similar way, if your schedule does not have any time, a wiggle room, a slack time on it, then she says you as an individual, you as a team, as a company will never be able to innovate. I came across this tweet and I thought this was brilliant. The tweet, I don't remember who said this, but they said that, what do you mean we have to fix the fences? We are so busy chasing the cattle. That's a beautiful way to think about it. What do you mean we have to fix the fence? We are so busy chasing the cattle. What do you mean we have to write automated tests? We are so busy fixing the bugs. And we can kind of resonate this kind of approach for a lot of things. But we really have to have time on our schedule when we don't have to do anything. And when we have the time when we don't have to do anything, we can focus on improving what we do. And based on what we learn and based on what we discover, we can actually reduce the time it takes for us to get the work done. This actually is pretty interesting to observe from this book I came across, Guns, Germs, and Steel. And Jared Diamond talks about there was a time when humans were predominantly hunter-gatherers. And all they did was they had to get up in the morning and go hunting every single day. Can you imagine if you have to go hunting every day, and the day you don't go hunting, your family cannot have food? Well, then humans eventually discovered they could do agriculture and they could domesticate animals. Just sit back and think about the time when this first happened. Somebody goes to Bernie and says, Bernie, why are you not going hunting? And Bernie says, I don't need to go hunting today because I got a lot of grains on the store and I have domesticated all these animals. And Bernie spends his time playing with this little lamb, and when he's hungry, he just kills it and eats it. I mean, this is amazing that you don't have to go hunting after all because there's food available. Well, then what do you do all day if you don't have to go hunting? Well, the civilization started growing. People started investing their time into creating art, creating music. So there is a very good correlation when humans didn't have to really survive for their food every day, and they can sustain a little longer, and then we could do other things to improve. And that kind of comes back to that quite a bit. So on a schedule, we should have time for development, sure. We also have to schedule time for paying the technical debt, but also include a slack time that becomes very critical. The next thing I want to talk about here, practice is to favor high cohesion. Now, some of these practices, I'm sure everyone has heard about it, but maybe it'll help you to rethink about it a little bit. Maybe you can go back and help your team to get better, or maybe there's a few practices I'll mention that you can go back and use it. Well, in terms of high cohesion, everyone says we have to make the code very highly cohesive. But what is it and why should we do it? I'll start with the why question again. Well, cohesion is where the code becomes narrow, focused, and does one thing really well. And one of the reasons why we should really do this is it minimizes the frequency of change to the code. So the less frequently a piece of code changes, the less expensive it becomes to maintain it. If a piece of code does several things, it has to change several times. If a piece of code does only one thing, it has to change just once. This is something we all need to really think about when it comes to writing code, because when you look at a function, ask the question, what does this function actually do? Sometimes you wonder, what does this function not do? Because it's so big after all. But every function has to be focused and narrow. My parents really tried hard to teach me cohesion when I was a child. But I was absolutely a stupid child. It was much more fun to go out on the street and play. And if you ever came back in time and looked at the little Venkat, he was horrible. I would come from school, open this drawer and throw things in, and I would run away to play on the streets. If you ever open that drawer, I cannot guarantee what you will find there. There'll be books, of course. There'll be clothes, some used, some not. And there will be also toys. There'll be, other things, snakes, for example, who knows. But the point really is everything was in this one place. And they would always tell me, how do you find anything here? Well, it was optimized to throw things in, not to take things out. Like code is optimized to write, not to read. And essentially, it was like tornado went through that little zone. And if you ever opened it, if you find a red sock, the next sock will not be red in color. I know what you're thinking. You're thinking, this guy sounds like a disaster in the making. How did he end up here like the way he is? I'll tell you how. I got married, and that took care of everything for me. And the point really is, now the books are on the bookshelf. What a concept. And the kitchen has the knife, not my table. And everything is very disciplined. Things belong where they belong. That's cohesion. So you want to definitely make code really cohesive. Well, a code is highly cohesive generally means it has low cyclomatic complexity. This reminds me of an experience I had. I was visiting a client and I was talking about code quality, I'll talk about high cohesion, but these guys have a very unique opportunity on their hand. They have been developing this one software for 30 years. And all that 30 years of software is in one version control. And when I go to them, it is a little bit intimidating for me all the time because there are some people in the company who wrote the first line of code on that software. And they are still sitting there and they're still thinking what they should do if they would retire first or die first. And they're just sitting there and waiting. And one of the developers called me and said, let me show you something here. And it takes me to his computer. He drags the timeline in the version control to 15 years ago and showed me this function. That's the day this function was born. Beautiful looking function. I could see its entire naked body in front of me. Beautiful name, just 2 parameters. I could see it from top to bottom. What a cute little baby function. I was admiring it. He said, look over here, and pointed to the cyclomatic complexity, a value of 5. A value of 10 is considered complex. It had a value of 5, not bad. While I was admiring it, he said, don't get carried away. And he grabs the handle and moves the timeline to the current date. And in front of me, I saw that function turn into a monster. And I don't see its bottom anymore. It is that long. And don't even ask me how many parameters this function now has. And then he points me to the cyclomatic complexity, a value of 864. And then he said, that's what we do to code in this company. I'm like, where's the nearest door I want to run? And it's kind of scary when the code becomes a monster in an uncontrolled manner and we can't do anything about it. So we have to constantly keep a tab of the code and refactor it to reduce complexity along the way. Well, the next principle here, practice here is we should favor loose cohesion. Well, sure, we've all heard about favoring loose cohesion before, but I've got a little bit of a twist on it. Well, why should we really favor loose cohesion? Well, tight coupling. If you ask me, what is the worst keyword in Java? And I'll tell you, the worst keyword in Java is new, because entire framework has been written so we don't have to use new. And this is amazing, isn't it? You go to people and they talk about abstract factory. When everything is said and done, you say, why are you doing it? Because I don't want to call new. And new is the most ugly keyword because new means we have tight coupling. You don't want to tightly couple to this class. You want dependency injection. You want to be able to switch between implementations. Well, sure, tight coupling leads to code that's really hard to maintain. Tight coupling makes really code hard to extend as well, and the code becomes incredibly difficult to test it as well. Well, sure, we all want loose coupling, that's great, but I want to go a step beyond that. I don't want loose coupling. I want to get rid of coupling as much as we can. So I'm of the opinion that we should eliminate coupling rather than trying to loosen the coupling as much as we can. Now, why should we really do this? Well, the problem is if we entertain a coupling of any form, whether it's tight or loose, we end up actually creating mock objects and stubs to manage them when it comes to testing. And the more mocks and the more stubs we create, the more it is difficult to maintain the code. By eliminating coupling, we can save all that effort. But how in the world can we eliminate coupling? I'm going to say there are 2 kinds of coupling we normally deal with. One I call as true coupling, and the other one is an accidental coupling, something that we get into when we really don't have intention to really, because maybe the problem statement said we have to deal with this coupling, and then we kind of get dragged into it. So here's an example I want to talk about. So here's the code on the left, and that talks to the code in the middle, and that one, of course, talks to this code on the right side, and that one, of course, is very unpredictable, non-deterministic. How do I really test the code in the middle? Well, by clearly creating test doubles, stubs, and mocks to really test it. But that can make the life really hard for the person maintaining the code that is in the middle. Maybe we can reconsider this. If you look at this code, the code in the middle is receiving this input on the left, but it is also getting this data from here. Why not invert that for a minute? And let's say this code in the middle is now going to get 2 pieces of input. And after all, because it's getting 2 pieces of input, I remove the dependency from this. You might argue I just moved it, but nevertheless, testing this code becomes a lot easier now because I don't have to deal with the dependency. But then the question is, because we moved it over here, is it really making this particular code really hard? Well, the answer to that question is, this one is usually a fine-grained access. On the other hand, this one becomes a lot more coarse-grained access. And as a result, it becomes a lot easier to work with. So one of the things I do these days mostly is I don't just take the dependencies and work with them and start creating test doubles. I spend quite a bit of time and effort asking the question, how can I remove the dependency or at least move it away, and I can save quite a bit of effort in the process. Well, the next principle I want to talk about here is to program with intention. And I think we all can agree to this point because we have seen this quite often in the code. And the sentiment is something every developer will agree to. And it says that when I wrote this code, only God and I understood what I was doing. Now God only knows. So this is so true. You're looking at this piece of code and you're trying to understand why you even ever wrote this code or what it is actually doing. And that becomes really hard to maintain the code in the long run. So when it comes to writing code, we have to program with intention. But sometimes you may say, we are writing code not with intention. We are trying to make the code really work. The other day I was at a client site. I don't know much about their code, but we were refactoring it. We had automated tests running in the background. And I took this particular code, refactored it, and I provided an index value that I wanted to use in it. And the minute I put an index value in the loop, the test immediately failed. And I turned to my colleague and said, hey, look, I sent the index. It doesn't work. What should I do? Immediately, my colleague said, try index plus 1. So I tried index plus 1. I didn't even speak a word. I just put index plus 1, hit the save, and the test failed again. I kind of shrugged and stared at him. Without missing a beat, he said, try index minus 1. I'm like, are you serious now? And he said, okay, maybe we should really think about what this code is doing. That's a great idea. Well, that's not called programming with intention. That's called programming with desperation. You try to do things until it works, and you say, does it work now? Yes, let's go to lunch now. Don't touch it. And we are trying to get things working. Really, that's not a way to develop software. This is one of the reasons I'm a huge fan of this Kent Beck's rule for simple design. He talks about 4 rules, and these rules have served me really well, and I just absolutely love them. The first rule, well, he says the rules are in the order of most important to the least important among these 4 things. The first one he says is the code passes all the tests. There's an implicit assumption in there that there are tests actually there to pass, but the code passes all the tests. The second thing is the code reveals intention. When you look at a piece of code, you should be able to say what the code is doing, what its purpose is. And the third, of course, is no duplication. Notice removing duplication actually comes after revealing intention. You don't want to really remove so much duplication to the point where you can't even understand what the code is doing, so there's a compromise in there. And finally, one of my favorite is fewest elements. And this says that minimalistic design, parsimony, as little as possible you can get away with is what you want to do. Again, keep in mind, if you say fewest elements, I always question, do you need this interface? Do you need this class? Do you need this method? And I will constantly ask people to remove things, but you may wonder, if you create this one God class which does everything, that would be absolutely minimum, isn't it? Well, yes, but if you do that, the code will be really hard to test because it becomes a ball of mud. Forget about revealing intention. It's really hard to understand. And so as a result, it's a balancing act. You wouldn't go to that extreme because you'd have totally compromised on other more important principles in there as well. So this is what he calls as 4 rules of simple design. Well, we have to program very deliberately. And to program deliberately, one way we can achieve that is to write tests before we write code. When I write a test, even before I have a piece of code in place, I sit there and think about, why am I writing this? What do I want the code to do minimally at this point? And then I bring in minimum code to make the test to pass. That can be a very disciplined way to drive that. Well, the next practice I want to talk about here is avoid primitive obsession. Well, this is a problem that a lot of us face. We feel that we have to write code, all the code all by ourselves. And we keep writing all this code over and over and over. Reminds me of an experience. I was looking at a piece of code. It was 30 lines long, so you would argue it's not too long. But I read the code, and something really bothered me. So I kept staring at this code. I said, why don't I not like this code I'm seeing in front of me? Then I realized that this 30 lines of code was doing a string manipulation. And I asked myself, this developer took all this time and effort to write this piece of code, but what if this code is already implemented maybe somewhere else? And I searched a little bit, and to my surprise, I found that this method actually exists in the JDK with two differences. One is he didn't have to write it, it was already there, he could reuse it. And the JDK implementation did not have the two bugs this code already had. So the point really is, why do we want to really write all this code when it's already there? And all I did was I commented the code, put that one call to the JDK, made sure the test is still passing, and I quietly checked in the code. An hour went by, the developer came along, looked at the code and said, gosh, Venkat pretty much commented out everything I wrote, and thinks about it for a minute, deletes the commented code, and checks in the code and walks away. I think that's a really good way to communicate with the team, that they have really put the time writing something that's not needed. Well, these days, I ask my developers to ask a very important question when they sit to write a piece of code. Ask the question, are you the chosen one? If you are the chosen one, you should write the code. If this is a very general purpose code, I'm really sorry to say somebody else was chosen a long time ago. And they probably, with all respect, wrote a better code than what you and I can write. And of course, if you're working on a very domain-specific code, the chances are you are the chosen one and you should be writing that code. So in other words, we should really avoid writing code at the lowest level and start using libraries and functions and higher abstractions as we can. I'm going to say that imperative code is packed with accidental complexity. Well, when you write code in the imperative style, you are struggling so much to do things that are created not by the problem domain, but created by the solution you chose to use. And we see this a lot in what we do. Let's look at an example here. Here is a function, and it says println compute. I have a function called isPrime that tells me whether a given number is prime or not. But compute, what does that do? The compute function is going to return the total of square root of the first k prime numbers starting with n. To be fair, this is not rocket science. It's a very simple piece of problem. We should have a simple solution for a simple problem after all. But how do we write the code to do this in the imperative style? Let's give it a try. What's the very first thing we're going to do? Well, the very first thing we will do here is to say double, and we'll say result is equal to 0. Then we will say index is equal to, well, n, of course. And then we'll say count is equal to 0, and then eventually we'll return the result. What did we do so far? Absolutely nothing useful. We just spent our time creating what are called garbage variables. Then what's the next step? The next step here is we will say while, and we're going to say count is less than k, and your mind comes to a grinding halt, and you ask the question, is it less than or equal to? Do you ever ask that question? Every single time. There is only one purpose of a code like this, to make us feel really stupid. Because you're going to look at that code and say, huh? Is it less than or equal to? And you're trying to do a boundary match. Maybe I'll stop here, or maybe one less than that. You're never sure about it. This is called cognitive load. You got to stare at that code, calm down to think about it. And you are never sure about it. In fact, this is what happens when you're a programmer writing code like this. You are at home. You know, a programmer never leaves work. We know that, right? So you're at home and you are having dinner with the family, and they look at you and say, you feel a little pensive. Are you okay? Yeah, I'm fine. Are you really okay? I'm really fine, I tell you. I'm not sure if it's less than or equal to, right? That keeps bothering us all the time. Then what do? You say, all right, in good faith, I'm going to say less than. Then you say E is prime, and I'm going to pass the number index over here. And if it is, what am I going to do? The result is plus equal to, and then I'm going to say math dot square root of that value index. So we'll say index right here. And I'm going to say right there, total of the square root of the first k prime numbers starting with n. And I'm going to ask you the question, is this code correct? What do you think? Am I missing something here? Yeah, what am I missing? I have to increment the index. Great. I'll increment index. Anything else? Increment the count, I hear you. So I'll increment the count as well. Is it correct now? You're thinking, and you're saying, no, it has to be outside. Okay, I'll move it outside. Is it correct now? You're saying, no, this has to be inside. That, how do you feel about that? That's complexity, isn't it? Now I'm going to ask the question, is the code correct? That's a nice expression right there. He said like that. So we went from it's wrong to I'm still trying to figure it out. I'll tell you, programmers are the smartest people on earth, because when you show them a code and ask them, is it correct? They will always tell you it looks good, because they would never tell you it is correct. Very smart, isn't it? Because 3 weeks from now, when we find a really disastrous bug, they'll say it only looked good. And that is basically the idea behind it. So, of course, in this case, we wrote a code in good faith. I'm going to run that code and see what it does. And in this case, of course, count plus plus. Let's go ahead and run this code and see what it wants to tell us. And it tells us that's the result. You could ask the question, is that the correct results? All I can tell you is it looks good. So that's basically the solution we got. But if you look at this code, that is a lot of complexity in the code. I have a theory about code like this. It is code like this that prematurely turns programmers into managers. They have said, I am done. You guys can play with this. I am going to go do something useful with my life. And they go away. I travel a lot. I'm in an airplane often, or in a car, and people next to me always tell me, I used to be a programmer. And I always say, I understand why, right? Because you in this room, you have a name. You are called survivors. Because I know some of you are so experienced, you may not remember this, but I want you to just think about the very first day you ever wrote your first piece of code. What happened? You typed that code into the editor, and you were so excited. You said, oh my gosh, I wrote my first program. And then you realized you have to compile it. And then what did you do? You ran the compiler. What did the compiler do? It literally spat on your face. And you were in a state of shock. You said, what just happened? And then they have warned you. This is what compilers do. And you said, I am not going to quit. And so you wiped your face and said, I'm going to do this for a profession. And you got back with vengeance. And 20 years later, what does the compiler do? It still spits on you. And you just wipe it and keep moving, right? That is the tenacity you have as a programmer. We are the survivors, if you will. But we could maybe do this a little differently. Let's give it a try. So what I'm going to do here is, rather than putting so much effort in here, why don't we try to do this a little bit differently? What about starting with maybe a return stream.iterate? Well, I'm going to start with n, but given an element, I want to return an element plus 1. So we are asking it to go through an iteration, and this, of course, is known as an infinite stream. So we start with n, but we got n plus 1, n plus 2, n plus 3, and so on. Then what do? Then we say dot filter. Given the element, I'm going to say, only give me, please, the prime numbers. Then what do? We'll say map to double, And in this case, we will say math, and we will call the square root method. And then we will say limit k. And you might be wondering, is it less than k? Is it less than or equal? It's k, damn it, keep moving. So you don't have to really spend the time confused about it. And then, of course, you perform a sum operation, and then you run the code, and you get the results right away. But the beauty of this is the code begins to read like the problem statement. Imagine you are sitting at your desk, and you have written the code like it is in the top. The business analyst comes to you and says, hey, what does this code do? And your answer is, that's what I'm trying to figure out, you shut up. And that's how we feel about it. On the other hand, if you look at the code like this, you could actually have a conversation with them and go to lunch as well with them. Hey, given the numbers starting with n, I get only the prime numbers, but then I found the square root, but only k of them, and I totaled it. Does that make sense what you want to do? So what does this really feel like? What it feels like is that a good code should read like a story, not like a puzzle. Now, how many times we write code where the code feels like a puzzle? You write a piece of code and your colleagues simply don't get it. They may take a couple of days sometimes. Sometimes they take a few weeks. Sometimes they even take a few months to figure out. It's a Wednesday afternoon, 2 o'clock, very quiet time in the office. You're coding away, and suddenly you hear the scream from the next cubicle. And you're like, they got it, right? So eventually, the puzzle you planted took so long to get it. Well, keep in mind, when your colleagues discover the puzzle, they are not going to be quiet. They're going to turn around and return the favor to you. And so in the meantime, we have production code to release. So a good code should read like a story, not like a puzzle. And the minute you read it, you should really know what the code is doing, rather than having to decipher through the code and ask, what does it really do? Well, this is one of the reasons I'm a big fan of functional programming, because, well, it turns out in the imperative style of programming, we tell what to do, but we also tell how to do it. Well, on the other hand, the functional style code is actually declarative. Not all declarative code is functional, but all functional code is declarative, and that is one of the benefits we get. So a declarative code, a functional code is actually declarative style plus the use of higher order functions. So one of the reasons why functional style code is so powerful is because we really are expressing declaratively, and that lowers all that accidental complexity we normally get dragged into when we write code in the imperative style. Well, the next practice I want to talk about here is to prefer clear code instead of clever code. Has anyone here not written clever code? Everyone has, right? But the question is, why did you write clever code? I'll tell you why you did. Because it feels really good. And the minute you write the clever code, that proverbial hand comes and pats you in the back and says, oh, you are so awesome. And you have the urge to go tell your colleagues, did you see this code I wrote? And they look at it and say, I don't get it. And you beam with pride and say, let me explain to you. No, no, wait, I'll figure it out. And you say, I'll come back to lunch and see if you got this. And this is what we do. We go home and tell our mom and dad, look at what I did at work. I did this and nobody really figured this out yet. This is like how genius I am. So clever. In fact, this is the reason why I like interns from the university. Because when you hire the interns to say, come work with us in the summer, you should follow them to the university in the semester when the semester starts, because they go to the university and say, this company I work with, these people are genius. I understood nothing of what they do. And this is basically the problem here is we espouse this cleverness, it becomes really hard to maintain the code. Well, in my own experience, I learned this the really hard way. A client of mine said that we need to make an enhancement to the application in a particular pattern of access. And I told them, oh, no. I don't want to really improve that particular area. I could do this in 10 minutes and I could walk away. But no, I want to solve the mother of all problems. I'm going to solve the problem in a way, not only will this be handled, a pattern of these things will be handled. I spent an hour writing the code. And when I finished, Literally, I had an out-of-body experience. Venkat got up and came and hugged me and said, "This is awesome coding, brother. This is awesome." And I checked in the code. And a couple of weeks went by, and I got this email from the client saying something terribly has happened in production. I replied immediately saying, "I'll take care of it. I'll fix it." They said, "Oh, of course you will fix it because we know you're good." I said, "No, no, no, no. I'm going to fix it not because I'm good. I'm going to fix it because I caused the problem." And the solution had put in place was totally broken, and it fired back in ways I never imagined. So what did I do? I rolled back the code I put in, and then I wrote the 10-minute solution I had in mind initially, put it in, and never heard back from them about that problem. Now I have learned a very important lesson. These days, when I write a piece of code, my little brain says, "Oh, that's a clever solution." I immediately delete it. And I start over again because I want clear code, not a clever piece of code. So when it comes to this, a beautiful code by Abelson and Sussman, and that is programs must be written for people to read and only incidentally for machines to execute. We often optimize code for writing when we should really be optimizing code for reading, because a code is read more times than it's written. It is rewritten more times than it's written as well. So we should really focus on optimizing for that. And that's where we should really ask the question, how could we make the code expressive? How could we really avoid cleverness in it, where the code becomes really easy to understand? Well, I'm going to say 10% of the time we write ugly code for performance reasons. The other 90% of the time we write ugly code just to be consistent with that code. And this happens a lot. I remember one day sitting at work, a young developer comes and sits next to me with a little thud and a sigh. And I said, "Having a rough day at work, aren't we?" And he said, "You know, I just came from this meeting. This developer had written such a horrible code that nobody can understand it." And he says he had to write the code that way for performance reasons. What do you think about it? I said, "I won't answer that right now, but let me ask you a different question." I said, "Does the code have a good performance?" He said, "That's the problem. It doesn't." Well, the point really is that those who sacrifice quality to get performance may end up getting neither one of them. So now you have a code that is so horribly hard to maintain, and nobody can even improve it to improve the performance, and that becomes a complete disaster. So we really have to make the code readable first, and then come back and improve the performance, but only when such a performance is actually necessary, not just because we feel that we have to improve the performance in that area of code. Here's another beautiful quote by Tony Herr. He says, "There are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies. And the other is to make it so complicated that there are no obvious deficiencies." So sometimes the code is so broken, we don't even know if it's broken or working correctly. And that is something we need to really take the time to, again, improve the quality of code we create. This one is a little off track of what we normally see, but I'm going to call this as the Zinsser's principle on writing, but applying it. Well, I came across a very old book. This book was created about 30 years ago by William Zinsser. He recently passed away, but he left something wonderful for the world. This book on writing well is about writing good English. This is not a programming book. This book is focused on how do we really write nonfiction? How do we write articles, blogs, technical books, and such things? And this book was really a way to motivate us to write better English. I started speaking English when I was 19 years old. And I then got excited about writing books. And the very first book I wrote, the people who had to review it, the editors, they were not called editors, they were called victims. And they had to read the book I wrote, and they poor people suffered through it. And when they finished it, they came back to me and said, "Is this your last book?" And I said, no, this is my first book. And they said, "So it looks like you want to write more books." And I said, "Yes, of course." And they said, "Dear God." And they gave me this book and said, "Read this book before you write anything else, because we need help." And so I read this book. And when I read this book, it was an eye-opener for me, because Zinsser talks about how do you really write good English. And I not only read this book, I read this really thoroughly, and I said, my gosh, there's so much he says about writing good English, I should really follow. But one thing that surprised me in this book was not just the fact that he said we should write it, we even outlined principles, and there's a lot of different quotes in the book. I praised this book a lot oftentimes, and I kept talking about this book so often, and my son, who was 10 years old at the time, came to me and he said, Dad, I know you talk about this book a lot, and he wanted to read some books in the summer. Well, in the US, we have a long summer holiday, and typically what he does is he goes and gets about maybe 20 to 25 books in the summer, and he just plows through them in the summer. And he said, and when he was 10 years old, he said, I want to include this book in my reading list. Can I borrow your book? I said, absolutely not. Don't even try to touch my book. It's mine. And I went and bought his own copy of the book and said, this is not a book you want to borrow. It's a book you should own. So I gave him his own copy of this book. He not only read the book, but he then told me it's a book not to be read. It's a book to be reread. That's what he said. And I know that he has not just read it once, but he has read it 4 or 5 times already. And I know it because we'd be reading something in a completely different context, and he would suddenly quote something from the book without looking at the book. He would say, remember what Zinzer said, and he would quote something from the book and say, here's what the author has done, and relate to it. So what does the author really say about writing good English? He outlines 4 principles. Well, it so turns out the 4 principles he talks about writing good English are also good principles for programming as well. And here are the 4 principles he talks about. The first principle is simplicity. He says that when you write English, your English has to be really simple. If what you write is very complex, people are not going to read it. Same thing in code as well. Isn't that what we tell all the time? Make your design simple, make your code simple. But what makes things really not so simple? Well, in the code, of course, when we try to mutate too many things, it becomes complex. When the code is not cohesive, it becomes really complex. When it's too tightly coupled, it becomes complex, and so on. The next thing he talks about is clarity. He says what you write should be very clear. And I have written books, but these days I read more books before they are published than after they are published. The publishers contact me and say, would you read this book, be a reviewer, and which is a very noble thing to do because I get to learn from the author, and while learning from the author, I can also help people improve the book they are writing as well. And I notice these authors making a mistake that I normally make myself, and that is when you're reading something, they talk about something here, and suddenly they talk about something here, and then they talk about something here, and you're going through this transition back and forth, and it's confusing you as a reader, and you're asking the question, what are we trying to really do here? It's the same thing in code as well. Sometimes we're rearranging the code, you can make it clearer. There is other things you can actually do to make the code clearer as well. For example, if you go back and look at the code we saw a few minutes ago, let's just look at this code for a second that you have in front of you. You can ask me, in this code, what is the most important part of this code? And I'll tell you, there are 2 lines in this code that is the most important. And those are this line here and this line here. And I'll tell you honestly why that is. Because those 2 blank lines are telling the developer, I am transitioning from one to the next step here. You're giving a little pause to the reader. And this is a very nice way to communicate without comments to the reader by telling them, hey, I'm done with this. Here is a pause. I'm going to the next one. This is why we write paragraphs, and we give a line between paragraphs. What is a paragraph? I'm a man of impatience. I don't read too many books because I get angry and irritated when I read books. I have a lot of books that are open, never finished. However, I started reading a book about a year ago, and it surprised me. I could not put this book down. And I was reading it in airplanes. I was reading it during dinner. I was reading it when I was in train. And I asked myself, I don't really have patience to read books, but why am I reading this book so intently? And I immediately answered, well, you're reading it because this is a topic that is very interesting to you. And I said, but a lot of other book topics are interesting to me also. Why do I just throw them in the corner? Why am I reading this book? And it suddenly dawned on me why I was reading this book. And the reason was every page had either 5, if not 6 paragraphs. And every paragraph was small. And what I noticed myself doing is I would read a paragraph and then I would look out the window. I would think about what I read. I would kind of think through it, relate to the concepts in my own experience. I would think of analogies. I would relate to these experiences. And when I was done with it, I would read the next paragraph. So this made it a very joyful experience because the author said, I am telling you this, it's your turn now. And the author is having a conversation with me by those little paragraphs and giving a pause between them. And I thought, that is brilliant. That is the reason why I'm hooked to this book, because there is these bite sizes of details and giving me the opportunity to digest them before I move on. And that was very effective for me. So that is whole point about this is to focus on clarity. The next thing he talks about is brevity. He says shorter sentences are better than longer sentences. Shorter paragraphs better than longer paragraphs. Shorter chapters better than longer chapters. Shorter books better than longer books, and so on. Well, isn't that what we say when it comes to writing code? We want to write shorter functions, smaller classes, smaller components, even smaller software. So we want to really focus on brevity quite a bit. The last one he talks about here is the one I rejected in the beginning. It said humanity. I said, humanity? We don't care about it. We are programmers. We focus on computer doing stuff. Why would we care about humanity? Well, it turns out that's the most important thing. Because in a civilized society, what do you do normally? When you are walking by the door, as you open the door and swing it open and you walk away, ever so slightly, you gently look behind just in case there's somebody coming behind you. You hold the door for a moment because you don't want the door to slam them. That is your humanity. When you write the code, you know there is always somebody behind you who is going to read the code and maintain it. And so ever so gently look behind and say, what can I do for the developer who's going to open this file tomorrow? I don't want to shock them and irritate them. So humanity is very important. But unfortunately, though, we give this impression that we don't care about humanity. And I'll tell you about myself for sure. I travel a lot and I'm in airplanes constantly. I take flights that are 10 hours to potentially 17 hours long. 10 hours or 17 hours is precious time. You could crank out a chapter in a book you're writing. I write a lot of my books in airplanes. So if you ever catch me in an airplane, from a distance you will notice this. I'll get in, as I sit, my laptop swings open. And I would start writing and coding right away. And I would never look at anybody around me. Because if they start talking to me, that's a waste of time. How do you want to really waste time talking to somebody? This is absolutely useless. So I'll be the most antisocial person in airplanes until I find the person next to me is a programmer. This changes everything. You have to talk about checked exceptions and garbage collection and whether semicolons are important and your opinion about JavaScript. And we will turn into a riot at this point because we got so much to really talk about. So I've come to this conclusion: programmers are not antisocial. We are social among the right kind of people. That's what it really is. And in fact, this is kind of crazy because the other day I was with the optometrist and she was looking into my eyes and she said, what do you do for a living? I said, I'm a programmer. And then a few minutes later, she said, what do you do for a living? I said, I'm sorry, I told you that I'm a programmer. She said, yes, I heard you the first time, but I just wanted to make sure because you look almost normal, she said. And we give this impression to people. Somehow we are antisocial, that we don't want to get along. But humanity is one of the most important features to think about in terms of writing code as much as writing English or whatever language you want to write it. That becomes very critical. Well, the next one I want to talk about here is comment why and not what. Well, we live in a world where people have this urge to write comments. I'm not saying don't write comments. What I'm saying is make your comments worthy. Your comments should tell why the code exists, not tell me what the code is doing. I've come across quite a bit of this pain over time. The other day, I saw this beautiful piece of code. It said I++ with this beautiful increment next to it. And I told the developer, thank you very much, because they know that I'm getting older. They know that as I'm getting older, my eyesight is really hard. And they said, Grandpa Venkat, in case you did not know, I wanted you to know we are incrementing. I said, thank you, grandchild. I was not sure if it was incrementing or decrementing, but it's absolutely clear to me now. But what I don't understand is, why are we incrementing, right? That's what we don't know. Or the other day I came across this code which beautifully said shift. And the question is, why are we shifting? What is that magic number we are using here? That is totally gone over here. So people have this urge to comment. But I'm going to ask the question, why do people write stupid comments like this? And I have this theory why they write it. Well, most of us, unfortunately, start writing code when we are in school or college. And then what do? You write this code because the professor said, go write the code. And what did you do? You wrote this beautiful code, which is easy to understand, easy to read, and you turn it in. And the professor comes to you and says, I am going to give you an F because there are no comments in this code. You protest, Professor, I wrote code everybody can understand. And the professor says, write comments or you get an F. Immediately you say, no worries, and you comment the heck out of it. And this becomes a practice over time. Then you come to the job. Well, good news, in your job, there are no professors. But there are other police who are there. And they tell you, you will write comment. What if I don't? No bonus for you. I'm writing comments. So we continue with this threat over time. It becomes a practice after all. We keep commenting the heck out of things because everyone tells us you got to write a comment. But the question is the comment really helping? In fact, it's even worse. I used to work in a company where they had commented, not just telling what the code is doing, they would have arguments in the comment. It will say, LK said this, but RK doesn't understand and doesn't agree with it. And they would just have a narration of what their feelings were. In fact, I just spent about 2 years reading it. One day, the company organized a party where they invited everyone who used to work in the company. I just opened the door and walked in. I saw 2 guys standing and talking. I went near them and just kind of looked at them for a few seconds, few minutes. And then I said, hey, excuse me, sorry to interrupt. Are you LK? He said, I am. Have we met before? I said, no, but I read your comments. I mean, I could feel his words. I could hear his words. And I'm like, this is dangerous. That's how you know they've actually heard this person. Well, actually read his comments. Well, the point really is we should really focus on writing self-documenting, self-descriptive code. So don't comment to cover up bad code. So if somebody tells you, I don't understand this code, write a comment, I say timeout. I don't understand this code, refactor it. So we want the code to be really self-documenting, easy to understand. So we want to write the code which is expressive and self-documenting. A good code is like a good joke. This is one of the rules I follow in life. You say a joke and nobody understands the joke. The worst thing you can ever do is start to explain the joke. Because you then explain the joke and people look at you and say, oh yeah, and what's funny about it? Let me re-explain it. That's going to be a very long dinner with this person. So when you say a joke, nobody gets it. The only right response is, never mind. And then you go home that night and you sit down and think about this and say, why did nobody get the joke? And you refactor your joke. And then you try it with a new group of people the next day and see how it goes. So a good code is like a good joke, and trying to comment a piece of code is like trying to explain a joke. This is never a good idea. So you want to refactor it so that people can actually understand it right away, and so they can relate to it very quickly than having to have the comment to say what the code actually is doing. Well, it turns out we live in a world where things get really complicated. I was in Washington, D.C. to speak in a conference, and in the morning before I went to the talk, I wanted to take a shower, which is a good thing. And so I stepped into the shower, and I got so angry, absolutely angry. I was intellectually insulted. And when you're angry these days, you don't take shower. When you're angry, you tweet about it. So immediately I jumped out of the shower, grabbed my phone, went back into the shower, and I took a photo and I tweeted. So what did I get so angry about? Because when I saw this particular shower, I said to myself the following: those who cannot design are condemned to document. And why in the world don't you make it easier to use than telling me how to use it? I mean, you see this all the time, isn't it? You walk to the door, on the door, in a very bold, it says, pull. And what do people do? They push. And it's like, why are people not reading it? Well, it's not like you are very busy. You walk to the door and say, calm down, people. You cannot think of anything now. Focus on the door because I'm going to open it, right? Well, the design has to be intuitive. And this has only gotten worse. The other day, I was having cold. And my wife said, maybe you should take this cold pill. I said, that'll be great. And I took the bottle, which had the pills in it. I should have just opened it and tossed it in my mouth. But without doing it, I just said, gosh, there's something written on it. I started reading it. Not a good idea. It said, take 2 tablets by mouth. And I'm thinking, what other option that we have at this moment? And it completely messed my mind at this point. I'm like, wow. And I'm looking at permutation and combination of things I could do with this tablet now. That's not a good thing to do. And this is exactly what you see. You see a function called, function name, comma, int p1, comma, int p2, comma, int p3. And you're like, why me? What does that P1, P2, and P3 mean? We have no clue. Well, read the damn documentation, they say. But why can't it be really easy to understand so we can actually understand what is going on immediately? So order 3, wow, what is this magic number called 3? Oh, that's a large cup. Why can't we maybe use an enum so it becomes really easy to know what this really means? So the question really is, how could we really make the code self-descriptive so we don't have to use the documentation as crutches, and instead we can use it where we really need it? So document the code using well-chosen meaningful names. Use comments to describe its purpose and constraints. Don't use comments as a substitute for good code. Well, so the next practice I want to talk about is avoid long methods. Who here thinks long methods are a good idea? Not a single person raised their hand. Let me ask you a different question. Who here has seen long methods at work? The hands immediately go up, right? This is called cognitive dissonance. I got some bad news for you. Well, the first is a good news. I know who did not write those long methods. You didn't. I mean, you just told me you don't believe in it. You didn't write those long methods. Then who in the world is writing those long methods? I got to tell you, the people who believe that long methods are a good idea are at work today, making those methods longer as we speak. So how do you really convince them this is a really bad idea? But why are long methods really bad idea? Well, long methods are really hard to understand. Long methods are hard to debug. Long methods are hard to maintain. Long methods are hard to reuse. Why? Because this is a very long method, and what you want is right in the middle. It says, I won't let you use me. And long methods lead to duplication of code. You are like, I will see how I can reuse it, and you copy and paste it. And that leads to duplication of code as well. Long methods are hard to test. Long methods keep us awake at night, and it's very hard to work with these kinds of software. We know long methods are really hard, and yet people do this. One experience I will never be able to forget. This was in Devox, Belgium. In Devox, Belgium, that room is intimidating. You're in a theater, IMAX theater. In front of you, there are 800 very comfortable seats. You as a speaker and everybody else in the room are this big in the magnitude of this room. And I shouldn't have said this, but I did. Right in the middle of my talk, facing the dark room, I asked the question, how long is the longest method you have used, you are worked with? And right from the middle of the room came a voice. It said, 40,000. I said, your entire class. He said, one method. I said, where do you work, in hell? And I finished my talk, and as I'm putting things away, this gentleman walks over and says, I am the one who said 40,000. And I will tell you, he was not kidding. I can see in his eyes, he said the truth that day. And I looked at him and said, seriously? 40,000 methods? He said, it's actually worse. I said, how could it be any worse? He said, I didn't know this, but I got hired full time to refactor that one method. I told him I didn't know such job exists in the world. Like, what is your title? Director of Refactor the Stinky Method? I don't know. That's kind of scary. This was 1 year after. I am just getting ready to give my talk. Same theater, same conference, just the next year. And this gentleman walks over to me and says, do you remember me? I said, how could I ever not remember you? And he said, I don't know, Venkat, but honestly, ever since I woke up this morning, I have a brotherly love towards you, if that's okay with you. I said, absolutely. I'll be your brother today. You can pour all the love on me. What do you want to do? He said, I felt like I had to come and update you on my project. And I said, absolutely, brother, go for it. Tell me how things are. Well, you know, we started with 40. I know you have 40,000. How are things? Oh, I've worked on it for 1 full year, and I'm here to tell you very proudly, we are now down to 30,000 lines of code. And he's been shaving away for an entire year. And I wished him good luck, and maybe one day it'll be 0 lines of code, right? So the point really is that it's kind of scary when you see it. So the question is, how do we deal with this? Well, you have tried your best ever to convince people, don't write long methods, but they're not listening. What do? I've got a suggestion for you, maybe one last effort. You go to the office on Monday morning, sit down quietly, start working. And your colleague, you know the one I'm talking about, one who writes long methods, will not change, comes to you and says, hey, you're at work already. Yeah, well, how was your weekend? You could tell this person, oh, my weekend was great. On Saturday, I went to the park with the children. On Sunday, I went to the movies. But don't say it like that. Instead, you say, my weekend, at 7 in the morning, I pulled the car out of the garage, took a left turn, drove for 7 kilometers, took a right turn, went for 3 kilometers. Can you believe it? They had a detour over there. This government never fixes things properly. We waste all of our taxpayers' money. But anyway, I took a right turn, had to go for another 6 kilometers to take the detour, and then I took a left turn. Just keep going like this for a while. At some point, your colleague will say, oh, excuse me, have you gone mad? You say, no, I've not gone mad. I thought I'll tell you how my weekend was, like the way you write code. And the point really is, we don't communicate to people like that. The way we communicate with people is we give them knowledge chunks. Oh, I went to the park on Saturday, went to the movie on Sunday. Oh, wow, what park did you go to on Saturday? Oh, the one by the main street. Oh, of course, I've heard about it. Is that family friendly? Yes, I took the kids over there. What kind of activity did they have? Notice you're not talking about the movie at this point. You're getting deeper and deeper talking about the park. Well, there's a name for this. This is called SLAP. No, not physically. But the point really is, this is called single level of abstraction principle. Single level of abstraction principle says every function we write should be focused on one level of abstraction, one level of detail. Hey, where did you go? What did you do for the weekend? I should talk to you at that level of the detail for the weekend. Went to the park, went to the movie. You don't want to go to multiple levels of detail and confuse the people. That's called communication. Coding is a form of communication. So we talked about the perils of long methods, and we want to focus on single level of abstraction. Well, the next thing I want to talk about here is giving good names and meaningful names. They say one of the most difficult things for programmers to do is to create variable names. This is hard stuff. I can never come up with a name that pleases everyone. It's a struggle. So here's my definition of a programmer. One who can name their children quickly, but has a very hard time naming their variables. And this is something we struggle with all the time. We come up with names and we refactor it. Come up with names and refactor it. How many of you refactor your children names? You go to them and say, child, you're 1 year old, we're going to change your name because I found better one, right? We kind of are really good in giving names, right? And also, how do you give a name to a child? You know, it's funny, right? People give absolutely ridiculous names for variables. How many times have you seen people do this? A variable called KPZWL. And the other day I looked at all this and said, I am going to predict what the next variable is. I could never do it. And then finally I realized that the programmers don't create these variables. There's a reason why these variables like K, J, and P are in the code. And it took me a while to figure this out. The reason it's there is the programmer is programming and suddenly there's a phone call. And they turn and say hello. And once they speak, they turn around and literally their cat walked on the keyboard. And they're like, oh my goodness. And they grab the cat and say, what a beautiful variable name you gave for my code. Now go play, sweetie. And then they just continue coding. Don't tell them to change the variable name. Beautiful name given by the cat. And so it is very personal, if you will. And they kind of take it in after that. But the point really is, when people give names like that, have you ever seen a person you say, hey, what's your name? Oh, my name is P. I'm sorry? My name is P. Is that your middle initial? No, that's my full name. Oh, your parents should have been programmers then, right? I mean, do we ever name them single letter? So the point really is we have to really give good names to variables. That becomes very critical. I was at a client site. I'm not kidding with you. A single license to this product is $1 million. And the people who work on this product are very advanced engineers. They hold utmost high level of degree. These people have created algorithms. They are the people maintaining the software. As I was working on the software, helping them on something, one of the guys brought a little piece of code, and then he switched over to another file. I said, oh, whoa, excuse me, can you go back to that other file? And he did. And I said, this is in production. He said, uh-huh. It's checked in, uh-huh. And we looked at the date. It's been checked in a while ago. I said, do you mind if I take a photo? He said, go ahead and take a photo, but you promise me you'll never tell who we are. So I said, absolutely, I will never tell anyone who you are, what company you are. And this is what I took a photo of. Oh, sorry, not this one. What I took a photo of was the line below this line, written by a developer. It said, God help me. I have no idea what this means. And this is in production code. And you may say, why did they not remove it? Out of respect. I think this developer died after writing this. Couldn't take it anymore, right? And they just kind of left it there saying, homage to you, what can we do? Well, the point really is, if that is the kind of code we have to develop every single day and maintain it, what an enormous burden we carry with us. And so when we name variables, just for a second ask the question, what does this variable mean? I strongly urge developers, please do not give single letter names for lambda parameters. You know, when people write lambda parameters, it is crazy. They put X, Y, Z, W, K. They're like, I'm sorry, what does all this mean? Well, if it's an element in a collection, maybe I can agree I for index. But if it is a patient data you're working with, and you're saying W, I don't have a clue what W means in this context. I'm scratching my head. And in fact, there are times when the developer who wrote it doesn't understand it after a few weeks, right? And so giving good names for even parameters to lambda expressions is a professional responsibility for us. Variable names represent abstraction, and if we cannot name a variable or a function appropriately, it may be a sign that we haven't really understood its true purpose. So we need to really take the time to give good names for these. The next thing I want to talk about here is to do tactical code reviews. And you may look at this and say, are you out of your mind? Code review? And this happens quite a bit in companies. What do a lot of people do? They invite people to a room and they do a code review. This is not a good idea. In fact, the boss may come to you and say, oh, excuse me, did I see your email that you're going to do code review on next Wednesday? You're like, yeah. Well, is it like what you guys did 2 months ago on a Thursday at 2 p.m.? You called everybody into the room and you did this code review as a team. Yeah. It's like, heck no. There's no way I'm going to let you do this, because last time you guys did this, there was a fight. We had to call the cops and 2 people quit. And no more code review for you. Well, why do people hate code reviews? Well, this is why I called it tactical code review rather than the word code review. We've been doing code review for a long time, but the way we do this is we never bring people into a room for code review. I work on a task, and the minute I finish the task, whatever small step I could take, I then give it to him and say, review my code, please. And the next task I work on, I give it to her and say, do a code review for me. A third task I work on, he might be working on this. These are people in my team, and I would rotate among them. Similarly, he finishes a piece of code, I review it in the meantime. We rotate among people to review the code. And when we review the code, there are a few things I want to emphasize. I'm a human as much as anybody else is, but I want to say that we should really try hard to do this. When it comes to review, never tell what is wrong with the code, and never even try insulting the person. We have to be very careful about it. Imagine you're looking at a very long method. A really bad review comment is, my dear God, look at this long method. Who wrote this? Oh, yeah, of course you wrote it. What school did you go to anyways? Is not a really good way to communicate with them. Instead, always propose solutions and suggestions. What about if you say, hey, I'm looking at this method. Do you think we should break this method into 2 smaller methods? Or maybe there's a better solution. Why don't we think about it? Or, hey, I'm looking at this variable. I'm having trouble understanding this variable. Can we come up with a better name? I am having trouble understanding it is not an insult on you. You have written a poor variable name, could be directed towards you. I don't understand this. Can we rename this to make it easier for me? So when you can propose that, that becomes really easy. A second thing I will tell you is that I don't review code. I review test, and then I review code. So my review starts with the test and then review the code. If they've not written the test, right there is the end of the review. You need to write test before we can review it. And when I review the test, if they're missing some important test, sometimes I get to work with really amazing people and their code is absolutely brilliant. They're better programmers than me. But a lot of times I would tell them, hey, you're really not writing these 2 test cases here that you may want to consider writing. So I would point out tests that need to be written more than code they have to change. A third thing, I started doing this about 9 years ago, and it's been absolutely rewarding. And I've learned quite a few lessons in the process. What I did back then was, when I find a bug, I would normally write a paragraph. Oh, I found a bug here in this code. If you send a value of 22, instead of getting a result of 7, you end up getting a result of -2, which is wrong, blah, 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 blah. And then I realized, why am I writing this description? It takes a little bit more time, but the very first time I did this, I found a bug and I quietly wrote a test that failed because of the bug. Writing the paragraph is easy. Writing the test takes a little bit more effort. And when I wrote the test failed, and I quietly checked it in, didn't say a word. The continuous integration failed. I said, I know it fails because I caused it. I deleted the email and said, I'm just going to be quiet. The developer who wrote the code got a notification too and said, oh gosh, I know Venkat was reviewing the code. Now the build is failing. What did he do? And the developer goes in and sees what's failing and says, oh, wait, that's not a test I wrote before, but the test is failing. And takes a look at it. An hour goes by. He comes over and says, aha, I see what you did there. I said, yeah, what did you find out? You found a bug and really nice, you wrote a test for it. I said, yeah, I did. I was able to fix it. He said, aha, but did you know there were 3 bugs in the code, not 1? And I'm like, oh, really? He said, but I saw what you did. You wrote a test for it. So I figured that's the right thing to do. So I wrote 3 more tests and then fixed those bugs. my job here is done, right? Because if you can promote the habit of people writing a test when they find a bug and then they fix it, that's what you really want to do. But having said that, I've been doing this for several years now, but until recently, I had an aha moment with that. I found a bug in the code. I sat down to write a test for it. And I spent a few minutes and the test wouldn't fail. And I'm like, wow, why doesn't the test fail? Here's a bug right in front of me, fail. It's like, no, I won't fail. And I spent more time on it and I could not write a test to make the test to fail. And that's the code to fail. And that's when I realized it was not a bug. I had just not understood the code properly. And now my recommendation was, oh, look at the code. It appears to be saying this to me, but now I understand it means something completely different. We need to refactor this code. And that can be really valuable because had you said there's a bug, they would have said there's no bug. Well, then you're talking about whether there's a bug or not, but now the point of contention here is not a bug, but we have to refactor the code because it ends up really meaning something other than what it truly is. It's not conveying the intent properly. So that can be a really powerful way to communicate that. So I'm a big fan of code reviews, and code reviews are extremely valuable because it can be a great way for us to keep abreast of the entire code base we are working with. You might have written this code. When I come to review it, it helps me to raise my awareness of what the code is doing. And by rotating it, you're also minimizing the risk of the project as well. People often ask, if people are doing pair programming, do we still need to review the code? And the answer to that question is, if two people are pairing for a long time, you definitely want to review the code. If they're rotating pair, in projects where I've done active pairing, we rotate pair every half a day to at most 1 day. So if you and I pair today, tomorrow you and I cannot pair. You will stay with the code, I will move on. And maybe, Mario will come and work with you. And the second day, Mario keeps the code, you have to move on. So one person stays with the code, the other one leaves, and then the rotation happens. In that case, we don't review the code, but even there we have an oversight where if you're working on something critical and complex, we would normally say, hey, we are working on this one, we have written something, we want somebody to review this. And in general, what I've noticed is a mature team invites people to review the code. A not so mature team hoards the code and says, it's my code, nobody should look at it. This is a sign of maturity on a project. If people are open for review, that usually means they're actually better because they have actually stood up to being critiqued, and as a result, they're actually better in what they do as well. The last thing I want to mention here is reduce state and state mutation. If you ask me if there is one thing I do today different from what I did 10 years ago, and that is write code with fewer states in it. I used to write bloated objects, a lot of fields, and now I realize I don't have to write so much code, especially not so much state in it. I tell developers now, let the state not be self-serving. Write the behavior and let it bring the state it needs in a very, very deliberate manner. So think more typeless, aim for minimalism, fewer state, less mutability, and just enough code for the known relevant parts of the problem. I'm going to be a little philosophical here. Well, when it comes to mutability itself, messing with the state is the root of many problems, both in software and in politics. We are beginning to learn this a lot, isn't it? So to stay away from state is a good thing, especially somebody else's state. And mutability needs company. It often hangs around with bugs. And that makes code really hard to maintain in the long run. We want to reduce the state. So having fewer fields, and when methods demand that field, cautiously bringing the field can help us. This is especially true when it comes to parallelism. We are trying to use parallel streams. I can't tell you how many times my developers turn into parallel streams, and then the state makes it really hard to make that work because the code runs really fast, but what fun is it when it gives you wrong results really fast? So you want to really refactor the code and remove the mutability from the code. So we talked about 12 ways to make the code suck less. We talked about scheduling time to lower technical debt, to favor high cohesion, to favor loose coupling, to program with intention, to program deliberately, avoid primitive obsession, write clear code instead of clever code, apply the Zinzer's principle on writing well, comment why the code exists, not what the code is doing, avoid long methods, apply the SLAP principle, give meaningful names for variables and methods, do tactical code review, and finally reduce state and state mutation. But I'll leave you with one closing thought. We are struggling all the time to write the software. We are constantly struggling to improve quality. We want to save time, but sometimes to save the time, we have to slow down to improve the quality. But there are a lot of pressure around us. People around us tell us, develop faster, release faster. And I'm going to say that the first step in becoming a better programmer is to let go of the conviction that we can code it once and get it right on the first write. It is all about rewriting code, not about writing it. It is all about making it affordable to rewrite the code and to refactor it. But we are under this enormous pressure. But at some point, our industry has to mature. We are driven by emotions. We are driven by irrational things in our lives, unfortunately. And as long as we are driven by them, we cannot do engineering. And if we want to do engineering, if we want to do science, if we want to do art, we have to really say, let's see if this even makes sense to do. I'll give you one example of it. I remember this experience a long time ago. My children are grown up today. But way back in time, when my children were very small, we wanted to take a day-long trip. We were going to go drive all day from morning to evening to before we get to the destination. So we started driving in the morning, early in the morning. I had driven for about 15 minutes with my wife on my side and the kids in the back. And suddenly one of my kids uttered the words, "Are we there yet?" And immediately I pulled over to the shoulder and turned off the ignition, put the car in park and said, "Yes, we are. We are there." And the kid kind of looked around and kind of chuckled and said, "No, we're not." I said, "Oh, you asked if we are there, and we are. We have reached the destination." And the kid said, "Daddy, we're not." I said, "So you know it." And the kid kind of stared at me and said, "Uh-huh. Well, because you know it, why did you ask then? Are we there yet?" And the kid kind of looked at me and said, "So here's the deal. I'm going to start driving. The next time you ask me, are we there yet? That will be the end of the trip. I'm going to pull over when you ask, and wherever we are at the time, that'll be the end of the trip. Do you understand this?" Yes. That was the last time they ever asked, "Are we there yet?" And my point is, if kids can understand this, project managers can understand this too. So the next time the boss says, "Are you done?" You say, "Of course. Let's ship it." That's all I have. Thank you. I'll be thrilled to take on questions, comments, anything you want to talk about. I'll be delighted to. Please.
You spoke about tactical code review. Do you think there is also such a thing as tactical pair programming? I mean, usually I don't like pair programming. I like to develop alone. But sometimes it happens that, I feel that I'm doing something that is very tricky. And at that point, I ask, "Look, please come to my desk and let's do this together." So you feel it's something effective, or you think that pair programming is something that you should do on a constant basis?
Well, I don't generally believe in this is the only way to do things. I think it is something we have to be willing to adapt. I would do the devil's advocate both ways. I've actually had people who will refuse to pair. And there are also people who say you will have to pair all the time. And I don't agree with either one of them. There are times when pairing is phenomenally good. And that is when you're able to think a little bit better. It helps you to stay away from a problem way too long. Sometimes we get so deeper into complexity when the other person could say, do we need to really do that? It's a great way for us to mentor and educate a fellow developer. And a lot of times we don't realize this. Mentoring is not a one-way street. We learn when we help other people to learn as well. Knowledge is a wealth that grows as we give. So every opportunity I mentor, I get excited because every opportunity I pair, I get excited because I learned something I did not even know before. Only because the developer says, why are you doing this? Or why can't we do it this way? And then you figure out better solutions, right? It challenges you in a way that you normally don't challenge yourselves when you're alone. But at the same time, though, there are times when I might want to sit alone and think about a problem. Maybe I want to say, why don't you go think about it? I'll go think about it. Maybe we can meet in an hour and see what we came up with. And that's definitely a good solution. But one thing we have to be very careful about. When I teach courses, I ask people to pair in my class. But let's say I'm teaching a week-long course. I would tell people to switch pair for every lab. So lab 1, maybe you both are pairing. Lab 2, I will say, you cannot pair with somebody you have already paired with, move around the room. In one company, this was just fascinating for me to observe and learn from. There were 2 guys who paired up in one of the labs, and they were so angry at each other. You would think they were married people. They're fighting like that. And the lab is over, and he said, I don't want to pair with you. They were like screaming at each other. And the next lab, I said, you have to pair with somebody else, right? And they're like, thank goodness. And they both go and pair with somebody else. And both of those new pairs, they're doing absolutely great. And this was, I just pointed them and said, you both were fighting so bad a few minutes ago. Look at how you both are doing so well. And I don't like him. I don't like him. Well, but let's honestly, that's the case. It's not like we hate each other. It's just that there are times when you work with somebody a little bit better than you would work with other people. There is chemistry, there is, physics, whatever you want to call it, right? But there is that, attitude. Sometimes 2 people just hit off and they do really well, and you may not really feel that way with somebody else. And don't force that on people. It's okay to, accommodate that and say, the goal is to get good results. The goal is not to follow a process. And that's what I would say. Do what makes sense, but be adaptive, and don't be stuck with saying that's the only way. Whatever that one way is that we should do it. I think the goal should be to get better results. Please.
So I actually have 2 questions. One is related to what you just said, which is do you think there is a way or some techniques that you have to get a feeling when a process would be the right one beforehand, before trying, instead of being adaptive and trying things and see if they work and changing if they don't?
That's a really good question, but I would say without committing, so this is what I tell my clients. Don't feel like you have to commit to this, right? You don't have to pair for 7 months. You don't have to pair for 2 years. I tell them just 2 days. Just give it 2 days and see how it goes. Just put your good faith into it. Don't walk in with the baggage. Tell yourself, I'm going to, honestly be objective and try this. And at the end of 2 days, or maybe it's a week, and then you say, we're done. We're not going to continue this, but now it's a retrospection. Let's see what we learned from it. And it's possible that some people will say, I really found it beneficial. I'm going to do this. Others may say, this is not for me. You say, all right, we'll give you the space. Take your time to figure this out. So to me, the thing is, there's no better way to learn generally than trying. But trying without commitment is a great way. This is something I do with my fellow developers. I also do with my children is I tell them, you don't even know what this feels like. So I'm not asking for commitment. Clearly, you're not required to do it. But Why don't we just try this for this much duration? But it's got to be long enough to get a feel for it, but not too long where we think we are kind of stuck in it, and we don't want to do that either. Yeah.
So my other question was not really related, but so we just saw 12 ways to make our code suck less. So let's just assume that tomorrow and from tomorrow on, our code will suck less. So how do you think we can spread the culture? I mean, you said you already mentioned some examples. Say, for instance, when you commit a test when doing a code review. So are there any other tools that you use to promote less sucking code culture?
So that's actually a really good question, and I think this is where this really goes back to a team's culture. But before I say that, I want to emphasize the word culture. Culture is not a country culture. I have been in large companies, and literally I'll be on 8th floor, but as I walk through the 8th floor, I'll go through 3, if not 4 different cultures. So the culture is very team oriented. These group of people may do things in a one way versus another one. When you have a culture where it is very healthy to be, which is safe to be honest. When you come and ask me a question, if I go to somebody else and say, you know what, he came and asked me this question, I can't even believe we hired him and he doesn't even know this, right? That is a very poor attitude. But it's safe for you to be honest. We're not going to badmouth you, especially behind you. That's first thing. Second is to be able to seek help, to be able to critique, to go to somebody and say, I wrote this code. I want you to tell me if there's a better way to do it. I always tell people a good code review is when the person writing the code requests for it, rather than you going to them and saying, I'm going to review your code. I've actually seen the situation happen in quite a few cases where the developer comes to you and says, the last time you reviewed my code, it was amazing. I was able to improve so much. I'm selfish. Can you review the code now? And that means you're not threatening. You're providing good value for them. And your behavior is inviting them to come back to you and ask for it. That can be very valuable. And a third is where you have these bursts of sessions where people can do rotated pair programming. A lot of times, what happens is I can look at a piece of code, but it's in a created state. But the challenge is not creating that code in that state. It's the thought process we go to create it. When I come and pair with you and sit next to you, and I see you struggle to come up with a good variable name, I know you have written really good code because it's in the repository, but seeing you go through that mental process helps me to see how you approach it. And that can be very valuable for me as a developer. And that's one of the reasons why collaboration, I think, is really, really useful in that point. Yeah, attitude, culture, collaboration can be very effective.
Reading the rule 8, avoid primitive obsession. How is possible to choose how to avoid it, but travel lightly when you are programming, in order to avoid to use framework just to do a sum of two strings?
Yeah, so it's not necessarily a framework. It's absolutely important to make sure dependencies make life really hard. Dependencies can complicate things. This is a combination of trade-offs, right? We can never take one practice and say, that's the only thing I'm going to use. It's a trade-off of multiple things we have to bring in. Given options that are available to us already, for example, I already use the JDK. I'm already using Java 8. I can easily use the built-in functions in JDK 8 that are not available in Java 7, JDK 7. I don't need a framework to be brought in for that. On the other hand, it also depends on the complexity of code you are writing. There are times I always ask the question, what is the cost of doing it? What's the cost of not doing it? If the cost of doing it is fairly high, but the benefit is less, I would avoid bringing those dependencies. If the cost of doing it is higher, not doing it is higher, then I would argue we should use the library or the framework. It's a trade-off. Uh, what is more important to me is not that we have made a decision. What is important to me is we have made an effort to make that decision. Either of those foregone conclusion is a bad thing. One is where we say, I will never do anything different. I'm going to be working in this level of abstraction is not a good sign. And the other extreme is, I'm going to always go reach out to other things and use them. I don't think we need to be in those polar extremes. We should say, here's what we have. Let's talk about whether we should really improve on this. Is there a benefit to doing it? What's the cost of doing it? And then we go towards it. It's a trade-off we have to evaluate on a case-by-case basis.
And talking about the cost, what I've noticed in my daily job is that sometimes, as a programmer, my idea of cost is completely opposite from the idea of cost of my manager.
Oh, are you a customer, for that matter? You're absolutely right. There are different costs involved in development. The cost of you implementing a feature, always ask the question, how valuable is this to my customer? If the customer's value is 5 cents, and if you're spending a lot of time and money building it, instead of building something that's more valuable. But for me, a lot of times, I will prioritize based on the business value to begin with. But then when I do it, I always ask the question, is it easier to extend in the later time? Is it hard to extend it? I'm not going to build things to extend it. I will actually minimize things so I can make it easy to extend. But you're absolutely right. We have to constantly ask, what are the costs? And I find it a lot better when I can vent it out, I can discuss it, I can elicit from a developer than me assuming it. I like to be challenged by people saying, oh, what do you think is the cost here? And am I even thinking correctly? Are there things I'm not even considering at this point? And that is very, very critical to have that. People to bounce off your ideas is a very valuable thing. That's one of the purposes of working in a team is that we can bounce off these ideas and do better. So you're absolutely right. We need to consider multiple costs, not just one way of thinking about it. Absolutely, yeah. Maybe one final question before we wrap this up. Yes, please.
How can we combine these wonderful principles with the brute reality of every day, where we are always late and we have no time, and the customer asks for a build, and we have no time to write good tests and good code?
That's a really good question. This is not an easy answer, but it's kind of like asking the question, how can I get healthy today compared to what I've done in the past, right? So you're hitting on something that is very important to realize. A lot of what we talked about here is not a mechanical process where you say, I'm going to do this tomorrow and it's done. These require change in behavior. It requires change in thinking. It requires consistent hard work. And here's the problem. When we are really good at what we do, we are able to produce the result. When we haven't really done a lot of these things, the cost of start doing this is very high. And a lot of times what happens is the fact that there is a burden on us sitting to say, you need to release what you have, a lot of times never gives an opportunity for us to even be able to get better at it. So what we need to do is to find a way to break that vicious cycle. So what I tell developers often is, they often say, what do I do with legacy code? And my answer is, you cannot fix legacy code mostly. Because we have taken all these years to build it, we cannot throw it away. But what I tell them is, your code today that you write becomes tomorrow's legacy. I think we can stop that from happening. So leave your legacy code alone, but for any new code you are beginning to write, try to, first of all, the change starts within. A lot of times people come to me and say, how do I convince my team? How do I convince my boss? And the first thing I tell them is, are you convinced? And if you are convinced you are going to do the right thing and then expect others to do it, versus I will do the right thing if everybody else does it. And so any new code we write, let's start really putting the effort towards it. Any old code we have written, you know what, don't worry about it right now. If we can get better at the new things we are creating, I think, and also this is where being realistic is important. Your effort in the long run, the short-term gain versus the long-term gain. Short-term gain, you can be fast today. Long-term gain, you can be more productive and faster in the long term, which means you may have to slow down a little bit now in order to gain that speed later on. This is where the maturity of the team comes together. We sit down and say, we want to get better. We want to lower the cost, over maybe 2 years, 3 years. For that, we have to start creating better quality code now. So we should be realistic. Let's not take away too many unnecessary features. Let's focus on more valuable features, implement them with better quality. So doing less with the better quality than doing more with poor quality, that kind of maturity and discussion can help a great deal. One of the things I've really found surprising in my experiences, and this is like eye-opening for me, I was sitting and talking to a developer, a development manager, a director, and every time I would come up with a proposal, they would keep telling me, oh, you cannot do this because our customers will never accept it. You cannot do this because what they meant by customer is the business analyst, the part of the organization that funds them. And after about 2 hours of going through this, I said, I don't think there's any point in you and me talking about this, because no matter what I come up with, your answer is going to be, they will never accept it. So I got a suggestion. If you really are interested in doing this, why don't you bring them over? Let's talk with them. And when I suggest something, let them say they will accept it or not, rather than you saying they will never accept it. He's like, sure. And the business analyst comes over, sits down, we start talking, and I said, we could do this, and here are the benefits. And the business analyst is like, you guys can do that? And it's like, yeah, that would be so great if you can. We have never had anyone say that to us before. We want this kind of development. And that's when you begin to realize we assume a lot of people will never give us permission to do things. But when we truly have the will, we'll find a way to do that, I think. So we need to work towards that. Thank you very much for coming. I really appreciate it. Thank you.